Alright everyone, so today is going to be lesson 10-1, the first lesson of unit 10, which is going to be right triangle trigonometric functions. So, this is the last unit we will cover in this class. Isn't that exciting?
Yeah.
This is our last unit, okay? So, this one is going to be what we're doing until the end, but luckily it's not bad. It's not bad.
Is it long?
It's long because it goes on to the end of the year, but there's a lot of activities involved and stuff that we do throughout. So no, it's not like a lot of homework more so than anything else. It's just like a more lengthy unit, yes. Because we are going to be doing it for the next like 4 weeks or so. Because the last 2 weeks of school is going to be like review and exam, so. Alright, so the term trigonometry was derived from the Greek word trigagon, or triangle, and metron, measure, and is the study of the angle and side relationships of a triangle. So, yes, there's a whole course on this topic, meaning we're only going to be scratching the surface in this class to prepare you for if you're taking trigonometry next year, just to get you like, amped up for it. But we're not going to be going as in-depth as the class does. So let's talk about the basic relationships between sides of a triangle. Now, does everybody recognize this formula? Everybody knows this one, Pythagorean theorem. Usually it's a squared plus b squared equals c squared. But they just put in the sides instead, the names of those sides. Somebody not?
No.
So that's Pythagorean theorem. You all know Pythagorean theorem. Thank you. Come on up to get a pocket. You're good. You're welcome. So now we have these things called the trigonometric ratios of sides, sine, cosine, and tangent. Everybody remember sine, cosine, tangent? And they have different side relationships. Sine is opposite over hypotenuse. Cosine of theta, this is what we call that angle theta, is adjacent over hypotenuse, and tangent is opposite over adjacent. So when I talk about theta, that's one of the two other angles that's not the right angle. And each picture will have that theta, or you'll pick a theta to draw in. And that's the angle that everything is in reference to. So opposite of this angle, adjacent to this angle, so on. So this theta is the measure of the angle. That's the Greek letter theta. So then we're going to talk about reciprocal functions, which is new to you. So every one of these trigonometric ratios has what we call a reciprocal function. Sine has a reciprocal of what we call cosecant, and it's just the flip. So it's hypotenuse over opposite. Cosine, secant is its reciprocal, which is hypotenuse over adjacent, and tangent has what we call cotangent, which is adjacent over opposite. So all it does is it flips the fraction. So if you're ever given one of those situations where you have to find it, you just flip that fraction, and that's what it's going to be. And you'll notice the calculator only has the regular functions. It doesn't use the inverse functions, or the reciprocal functions. Find the length of each triangle's missing measure, and then find the value of each trigonometric function. So here they give us a triangle, and we have one missing side. Now, do we have a way of finding that missing side? Yeah, what do we use? Pythagorean theorem. I think you're thinking of an area. But you have Pythagorean theorem. Now, what do I need to make sure about my triangle before I use Pythagorean theorem?
Right.
Oh, is that what you said? I'm sorry, I thought you said base. I think two people were talking at the same time. It sounded like you said base times height. No, you're right. Sorry, it sounded like you said something else. Yes, that's correct. So yeah, you have to make sure that you have a right angle in the triangle in order to use Pythagorean theorem. You can't just use Pythagorean theorem on any triangle. It has to be a right triangle. In this case, it is. This indicates it's a right triangle, right? So the sides they gave us, all right, which one of these is the hypotenuse?
41.
Good. So if you remember, it's always a squared plus whatever the other leg is, 9 squared, is equal to c squared, which is 41 squared. So the main idea here is that c squared always has to be the hypotenuse. Okay, the other two don't matter, but the hypotenuse has to be c squared. We do that math, we get a squared is equal to, it's going to be 41 times 41 minus 9 squared, which is 81. So 41 times 41 minus 81, and that gives me the square root of 1600, which is actually a perfect square of 40. So this side comes out to be 40. using Pythagorean theorem. So any questions about that part?
How do you know what, how do you know 9 was b squared and 41 was c squared?
Good question. Actually, A and B, it doesn't matter which one you pick for which.
Okay.
The only one that really matters is C because it has to be the hypotenuse. So if you're looking for C, you're going to leave that blank. But if you have C, you're going to fill it in.
So wait, so you do 9 squared, where did that go?
I just did the algebra, like I didn't do all the algebra out, like I just solved it like in my head basically here. So like this is 41 times 41, which is 1,681, and then I subtracted 81 on both sides. I just didn't do like the basic algebra out. But if you did that basic algebra out, you would have ended up with a squared is equal to 1,600 square root. So I just like skipped some intermediate steps just because for the sake of space. But that's it, yeah. I just solved using Pythagorean. So now that we have all three sides, we're ready to do our trigonometric ratios. So angle theta, they're either going to give you angle theta or you're going to basically indicate one. Theta is going to be the angle of reference, okay? So that's the angle we're looking at everything from the perspective of. So what is this side in terms of angle theta? Opposite. What is this side?
Hypotenuse.
Good. And this side is? Adjacent. So now that we have that information, we're ready to do our ratios. So sine is what over what? Good. Opposite over hypotenuse. Cosine is what? Good. Adjacent over hypotenuse. And tangent is? Good. Opposite over adjacent. Now, a little bit of a tip here. Sine and cosine will always be fractions less than 1 because the hypotenuse is on the bottom. It's the largest, meaning it has to be on the bottom, meaning it's always going to be less than 1. So the bigger number of sine and cosine will always be on the bottom. Now, how do we get the reciprocals? Well, we simply just flip them. So these are their associated reciprocals, and we just simply take the reciprocal of those fractions. And that's how you would get what we call the reciprocal function. And that's always the relationship. So sine goes with cosecant. Cosine goes with secant, and tan goes with cotan.
But how come the opposite would be where the adjacent is? Because like in the picture it said like the opposite.
The second one, aren't you supposed to flip that one?
Isn't it the adjacent supposed to be on the bottom and the opposite supposed to be on the
Oh, you're right, I didn't flip it. And I'm sorry, what was your question?
Why isn't like the opposite where the adjacent is and the adjacent is where the opposite is?
Oh, like why did I label these this way?
Yeah, because like on the picture up here it says it's different.
Because the angle theta always opens up to a side. So see how this angle opens up to this side right here? That's always the side that's opposite.
Oh.
The side that is basically makes up one of the angles is always the adjacent side, and the hypotenuse is always opposite the right angle. So theta can also be over here, like if they gave it to you over here, and then this would now be the opposite. So the opposite and adjacent can actually change based on the perspective of theta. Does that answer your question?
Mm-hmm.
Okay. Yes, thank you for that typo, by the way. I think I forgot to flip this one. Does anyone have any additional questions so far? All right, we're going to move on. So in this case, find the value of each trigonometric function. First thing we do is we see if we have a right triangle. Yes or no?
Yeah.
That means we can find the missing side by using?
Pythagorean.
Good. And which one are we looking for this time, A, B, or C?
C.
C. So it's going to be 3 squared plus 4 squared is equal to C squared. That comes out to be 25 equals C squared. And then we take the square root of both sides. That gives me C is equal to 5. So I just did 3 squared plus 4 squared. Square root that. So that gives me 5. And this is actually what we call like a special, I guess it's like a type of special triangle where they always 3, 4, 5 triangle. Have any of you remember that? 3, 4, 5? So yeah, some of them have common relationships. So now that we have that, we're going to look for theta. So I find my theta, and theta is what I look from the perspective of. So basically, pretend, I usually say theta is like where I'm standing. If there was like a triangle room, I'm standing at theta. That's the side opposite to me. This is the adjacent, and that's the hypotenuse. So from here, I'm looking for opposite, which is straight across. This is adjacent, and this is the hypotenuse. So now that we have all of that, we're ready to set up our ratios. So it's going to be sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now moving on, we are just going to take our reciprocals. So cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. Is everybody good with that?
Yeah.
Alright, let's try the next one. So this says use the given trigonometric ratio to find the remaining trigonometric ratios. So sometimes they're going to give you one of these and ask you to find the others. So the way we actually have to do that is we're actually going to have to draw our own reference triangle. So you're going to draw a triangle, and your right angle is, the one that looks like a right angle opposite the hypotenuse. Now you can pick either of these angles to be theta. It's just going to change like which way the triangle is positioned. So I'm going to choose for this bottom one to be theta, but you could have done the other one and your ratios will still come out to be the same. So now that we've identified a theta, we're going to use the information they gave us about cosine to figure out the other sides. So cosine is what over what? Good. So my hypotenuse has to be 3, and my adjacent, this is this side right here, according to my theta, has to be 2. So does everybody see how I got that? Now that we've found the sides that they gave us, we're now going to find the third side using Pythagorean theorem. This time we're looking for a hypotenuse or a leg? A leg. So that's going to be a squared plus 2 squared equals 3 squared. So you could have also plugged in for a and had a b. I just like to leave a because b kind of looks like a number 6, so it just makes it easier. So this comes out to be a squared is equal to, so 9 minus 4 is 5. I square root both sides. That gives me a equals radical 5. So this side here, we're going to leave it in simplest radical form, radical 5. So you don't want to get a decimal answer unless they ask you for one. Do not put it in a decimal. Simplest radical. Now that we have that, we're going to set up the rest of our ratios. So sine is going to be what over what? Good, radical 5 over 3. Opposite over adjacent. Opposite over hypotenuse. And then tangent is going to be what? It's going to be radical 5 over 2. Good. Opposite over adjacent. So is everybody good with these ones over here so far? Now we're going to move on to the other side, which is the reciprocals. So then we end up with 3 over radical 5. Now that's not wrong, but does anybody remember we can't leave a radical in the denominator, right? So we have to do what? Anybody remember the procedure we do? Rationalize. We learned about it a while ago. So technically you can't leave a radical in the denominator. It's not like proper. So what we do here is we have to rationalize. So the way you rationalize is you multiply the top and the bottom by the radical that's in the bottom. Does this ring a bell for you a little bit?
Geometry.
Yeah. So this is going to be 3 radical 5 over 5. That's how it's always going to simplify. So once you get the hang of rationalization, you can start doing it in your head too. I just wanted to show you what's happening. So yeah, that's the rationalized version. Now we're going to move on to secant, which is going to be what?
So you don't multiply what's in the radical, you just multiply and it gets rid of the radical.
Yeah, the reason it gets rid of the radical is because if I multiply radical 5 times radical 5, that's radical 25. What's the square root of 25? That's why it gets rid of that radical in the denominator. When you multiply a radical by itself, it's going to be whatever that number is on the inside. And what's secant gonna be? 3 out of 2, right? Flip it. And then the next one is going to flip to be 2 over radical 5, but we can't leave it like that, right? We have to rationalize it. And when you rationalize it, it should come out to be 2 radical 5 over 5. So is everybody good with the rationalization process? Yes, no, maybe? You ready to move on? Okay, so there's a little bit of a typo on your sheet, so just adjust it. It should be 17 over 8, not 8 over 17. We didn't catch it until we already sent the prints, and I wasn't about to resend all these prints for that, so. Alright, so as we can see, they gave us one of the ratios. We're going to have to draw a triangle to get the other. So we draw our triangle, and we decide on a theta. So theta, you have two choices. You can use either of the acute angles. It doesn't matter which one you pick. You're going to get the same answer either way. And now we're going to associate them. So if sine is opposite over hypotenuse, what would cosecant be?
Wait, do we change? So yeah, do we flip that 17 over 8 on our paper?
Yeah, so like it was just a typo. So you're just going to adjust that, yeah. Alright. So if sine is opposite over hypotenuse, what would this be?
Hypotenuse.
Over? Good. So the hypotenuse opposite the right angle is 17, and the opposite is 8. So now we have the sufficient information to use.
Wait, hold on. How do you know where the theta goes?
You pick which acute angle you want it to be. You don't. It doesn't matter.
Okay.
Yeah, your picture will just be a little bit like flipped from ours, but you'll still get the same answer in the end. So, what do we do next? Find the missing angle. Yeah, missing side, not missing. Yes, but correct. So that's going to be a squared plus 8 squared is equal to 17 squared. That's going to be a squared is equal to 225. I take the square root of both sides. That gives me a equals 15. So this side right here is 15. So everybody good with how I got the 15? This is another special triangle. It's called an 8, 15, 17. Now that we have that, we can go through and do the rest. So sine is what?
8 over 17.
Good, 8 over 17. Cosine is? Good. And tangent? Good. Now we're going to do our reciprocals, so you simply flip them. And that's what we end up with. So you'll notice that the reciprocal functions are not part of your calculator. And that's for the reason that you can always transfer them to a regular. One of the main, these are like the main, like, I usually like would joke that like these are like the stars, and the other ones are kind of just like the B-list celebrities. Like they're not really there, they're there, but they're not like the ones that you really see very commonly. So you can always convert cosecant to sine and so on. They can always be converted back. There are purposes for these that we'll talk about like in regular trig class, but for now, just know you can always convert them back. So does anybody have any questions about this so far? All right. So now we're going to move into special right triangles. So special right triangles are a super important part of trigonometry. They're kind of like the backbone to trigonometry, and you'll learn why as we go through this unit. But does everybody remember the 30, 60, 90 triangle from geometry? We use that a lot in geometry, right? We talk about the ratios of sides, and we talk about, if you remember, like the apothem, and how we find the area and stuff like that. So that's a lot of times that we use it. We're going to use it a little bit differently here. So let me refresh your memory. So a 30, 60, 90 has a special ratio of sides, okay? The side opposite the 30 we call by some variable, a in this case. The side opposite the 60-degree angle is whatever the 30-degree angle side is times radical 3, and the side opposite the hypotenuse is always 2 times the smallest side. Okay, that's the ratio. So they have this formula basically. Now, I want to show you what the most simple version of the special 30, 60, 90 right triangle can look like. So kind of think of this as like the parent function of the special right triangle. So simplest form. So let's say I wanted to make this side be 1. I can divide this by a, right? And if I'm going to divide one of them by a, I have to divide them all by a. You're basically just converting them all. So I divide all of them by a, and then I'm going to get something for my side. So what is a divided by a? Anything divided by itself is 1. What's a radical 3 divided by a? Good. And 2a divided by a? 2, right? So this is the simplest form of it. So the short leg is 1. The long leg is always the short leg times radical 3. 1 times radical 3 is radical 3. And the hypotenuse, the longest, is always 2 times the short leg. So 2 times 1 is 2. Works out. Okay. So that's the most simple special right triangle sides that you can have. Now we're going to look at our other old friend for 90, 45, 45, 90. You remember this one? So this is not only a right triangle, it's also an, starts with an I. Isosceles, meaning the two sides are congruent. The two shorter sides are congruent. So this triangle has another special side ratio relationship. The two small sides are like a, whatever they are, and then the hypotenuse is always a times radical 2. So whatever the small side is times radical 2 will give you the hypotenuse. So if you have one, you can find them all. So once again, to find the simplest form of this type of triangle, I can divide all of them by a. A divided by a is 1. A divided by a is 1. A radical 2 divided by a is radical 2. So these are my two legs, and this is my hypotenuse. Okay? So this is the most simple version of this. So the leg is whatever the leg is, the hypotenuse is radical 2 times that. 1 times radical 2 is radical 2. That's always the relationship they will always have. Is everybody good with that? So now we're going to move into how we would utilize these examples. So here we have a 30, 60, 90 triangle. Now they give us the 90-degree angle and they give us the 30-degree angle. How do I know that this is 60?
I have to add 180.
Good. Triangles have to have an interior sum of angles of 180. Does everybody remember that from geometry? So very important here. Now let's talk about the ratios of the sides. We know that 30 is a. We know that the side opposite 60 is a radical 3. And we know the side opposite 90 is 2a. So in this picture, which side did they actually give us? They give us the 2a one. So if we set this equal to 2a, what's a going to be here if I divide by 2 on both sides?
4.
A is 4. Which side actually is a? X. Very good, x. Because that's the side opposite the 30. And if x is 4, what would y be? 4 radical 3. It's always whatever that one is times radical 3. So if they give you one of those sides, you can always find the others because they have a formula, right? You can always find a, basically. That's kind of the key to finding all of them. Now we'll move on to the next one.
Oh, I have a question.
Sure.
So, like, do you just, like, leave it as the radical?
Yes, unless they actually specified to like give it like with 2 decimal places or something, always leave it radical because that's technically the only proper answer. Otherwise, it's always an estimate. Good question.
So, I'm a little confused. When you divide 8 by 2 and you get
4.
yeah, no, I know that, but I'm kind of confused where you get the like the radical 2a divided by 2. Like, where does that come from? And
Right here?
yeah.
Oh, that's just like me solving it. I'm just showing you how I solve for a. So I divide both sides by 2, which gives me A equals 4. That's just like me solving the algebra right there.
Okay.
Do you see what I'm saying?
Yeah.
Do we have any other questions on that? That was just me showing my work. Okay, moving on. So, here we have 90 degrees, we have 60 degrees, which means this angle has to be 30. Now remember, the ratio of sides is A radical 3, and 2A. Now which side did they provide us with? 2A. So we're going to set this equal to 2A. And then we're going to do what?
A equals 7.
Good. So we would divide both sides by 2 to get the fact that A is equal to 7, right? Is everybody good with how we got that? Now, which of these sides represents the A equals 7? X, because it's opposite the 30 degrees. Which means Y is the one opposite 60, and it would be what? 7 radical 3. Is everybody good with how we got those side ratios? So side values.
So how is y 7 radical 3? Since it's like opposite of 60?
Yes. So once you find the side opposite 30, which we found to be 7, you're good with that part, right? The one opposite 60 is always whatever the side opposite 30 is, times the radical 3.
Okay, so we found the opposite of 30 by doing 14 divided by 2.
Yes. Because the hypotenuse is always double the small side. So we just divide it by 2 to find it.
Oh, okay.
Does that make more sense?
Yeah.
Okay.
I got you on that.
Is everybody ready to try example 5? So example 5 is a different type of triangle. It's a 45, 45, 90, which has different side ratios. So this is going to be A, and A radical 2. Once we've identified that, we're going to figure out which side they give us. In this case, they gave us one of the small sides, which tells us that A is equal to what? 10. Now we notice that X and this side here are congruent, meaning that X is also 10. Now, I thought somebody said my name. Now we have the information necessary to find Y, right? Y is what? 2. So is everybody good with those procedures? So now we're going to talk about trigonometric values for special angles. So 30, 60, 90 angles are so commonly used in trigonometry, we consider them to be special angles. The side relationships of a 30, 60, 90 triangle and the 45, 45, 90 triangle can be used with SOHCAHTOA to find key trigonometric ratios. The common side relationships found in these special triangles, you should really remember them, okay? So I'll just tell you a story about this. So back in high school, I don't remember what class it was, probably Algebra 2 or Geometry. Our teacher gave us like a quiz where we just had to memorize these. And I don't know why in my head I was like, I'm just going to figure it out like on the day of the quiz. Like, as in like I'm going to actually do the math and like not memorize it, like just not listen to what my teacher said. And I was like, we were supposed to only take 10 minutes, so I was like sitting here trying to figure it out with the triangles. So basically, if they ever, which they will in trigonometry, if you take this class, they will ask you to do a quiz where you have to have these memorized usually. So you can't always just figure it out. So just a side note, so sometimes you will have to actually memorize them. Because you're not going to have time to figure it out. I taught trig last year and I had 2 students try to figure it out and they ran out of time. So anyways, let's talk about this. So we're going to talk about a 30, 60, 90 triangle. Now, there's many different sides that can exist on a 30, 60, 90 triangle. They're just all similar triangles. But we're going to talk about the most simplest form. So let's say that I make the side opposite 30, the smallest side, 1. Just like we talked about earlier. So you're going to make that 1. If that's 1, then what would the side opposite the 60 be? 1 radical 3, or just radical 3. And what would the side opposite the hypotenuse be?
Wait, Ms. Ross, I have a question.
Yeah.
So you know how this is radical 3, and why was it radical 2 on the isosceles triangle?
Because this is a 45, 45, 9. It's a different triangle. Different triangle ratios. So these are 2 totally different things. They have different rules.
Okay, so for
Yes.
And then for 45 is always gonna be radical 2.
Yep, they have different relationships.
Okay.
So now we're looking at a 45, 45, 90. So the sides opposite the 45, we're going to call one of them 1, which means the other one would have to be 1, and this would be radical 2. So you just pick for the smallest one to be 1, and that's the way to start. So now that we have that information, we're going to find the trig ratios based on these, okay? So your theta here is going to change based on what we're looking for. So in this column right here, we're looking for all the 30s. So in this column, we're going to treat 30 like our theta. So this is our temporary theta right here, okay? It's going to change, but it's our theta for now. So sine is what over what? Good. So in this case, opposite is 1. Hypotenuse is what? 2. Now, does everybody understand why we're using this triangle as opposed to this one? Because we're looking for 30. That's the one that has the 30 in it. Now, moving on to cosine. I'm going to do it down here, and you'll see why in a second. Cosine is what over what? Good. So it would be radical 3 over 2. Oh, this one doesn't come out that way. That one's fine. Radical 3 over 2 is fine. There's one of them we'll have to rationalize. I don't know why I forgot it's not that one. So the next one is going to be tangent. Tangent is what over what? Good. And what's the problem with tangent? There's a radical in the denominator, so we need to rationalize it by multiplying the top and bottom by radical 3, which actually comes out to be radical 3 over 3. So that's where we end up with. And now we're going to move on to the 45s. Now, which triangle am I going to be looking at for the 45s? The other one. Good, the right isosceles. So sine is, it doesn't matter which one you use as theta here because they're both 45, right? So they're going to come out the same either way. So this is going to be opposite over hypotenuse, which is 1 over radical 2, which is needs to be rationalized. So we multiply the top and bottom by radical 2, and we get radical 2 over 2 as our 45. Now if we do cosine, it's also going to be 1 over radical 2, right? Which also rationalizes to radical 2 over 2. Now we're going to do tangent, which is opposite over adjacent, which is 1 over 1, which is 1. So notice here that sine and cosine are the same. Anybody have a guess why? Yes, because it's an isosceles triangle, the two thetas are the same. I mean, the two acute angles are the same, meaning the ratios are the same. So now we're going to move on to 60. So 60 is going to be opposite. Remember, because now we're looking at a new theta, perspective of a new theta. We're looking at 60 as our theta now. So if we're looking at sine from 60, that's opposite over hypotenuse, right? So radical 3 over 2. Now we're looking at 60 again for cosine. That's 1 over 2, right? Adjacent over hypotenuse, 1/2. And then the last one is tangent. So tangent is going to be opposite over adjacent. So a radical 3 over 1, which is just radical 3. Now you're going to notice some special similarities and patterns here. What do you notice about sine of 30 and cosine of 60? Good. And then cosine of 30 and sine of 60? Also the same. And that's because of the relationships of the angles. They're always going to be opposite each other. And that's like a thing that always exists with this. Now we're going to move on to the inverse, or not the inverse, I keep wanting to say that, the reciprocal functions. So to get the reciprocal, we simply just take the reciprocal of these. Okay? So what's the reciprocal of 1/2? 2. What's the reciprocal? Oh, we'll do that one again. This one's also going to be 2. These are all matching. So like for perspective, this goes with this one, and this one goes with this one, right? So let's move on to the next one. We have to do the reciprocal of radical 3 over 2. 2, yes, good. So it's going to be 2 over radical 3, which is necessary to rationalize, which is going to come out to be 2 radical 3 over 3. So we have to rationalize it, And that's what we end up with. Now, to save yourself the work, work smarter, not harder, which other one is also going to come out to be this? Good, the 60. So you can see because they have the same original, they're going to have the same reciprocal. So now that we have that down, we're going to move on to the next right here, tangent. So for tangent, I'm going to have to take the reciprocal of this. Now, you could take the reciprocal of this and then rationalize it, but there's actually an easier way. Anybody have an idea? What did we do to get this? We had to rationalize it, didn't we? What was the original answer for this tan of 30? Wasn't it this before we rationalized it? Can I flip this instead of flipping this to make my life easier?
Yeah.
What's 1 over radical 3 flipped? Radical 3. So while you could sit here and flip this and then rationalize it, that's kind of a shortcut. Does everybody understand that? And this is one of those things, once again, you can just memorize so you don't have to think too much about it. Now moving on, this is the same situation. We're taking the reciprocal of radical 2 over 2. However, we don't have to rationalize it because what was this before we rationalized it? Yeah, it was 1 over radical 2 before we rationalized it, so I can flip the original, and that just gives me radical 2. This one is the same, so it's also going to be radical 2. And then lastly in this column, what's the reciprocal of 1? That's the negative reciprocal. We just want regular reciprocal. Just 1. It's just 1 over 1 flipped is still 1. Now the last one we're going to move on to is radical 3. So what's the reciprocal of radical 3? 1 over radical 3, right?
Radical 3 over radical 3.
You're close. Radical 3 over regular 3. Because you would have to then rationalize it, which we already did up here. So basically what I'll mention here is what kind of goes together. So this one and this one are reciprocals. And you could do this for all of them, like these are just reciprocals of each other. Okay? Now, like I said, you could figure this out every time. Or you could simply just do it, memorize it. So is everybody good with that so far? Do you want to take a break before we move on? Alright, we'll take a 10-minute break and then we'll pick back up. Alright, so now we're going to find missing side lengths. With right triangles, you can use SOHCAHTOA to find the lengths of missing sides. So if we zoom in, we can figure out which trig function will be helpful for this. So usually we look at what we know and what we want to know. So this is going to be our theta, so to speak, and we know the side what to the theta. Good, and we want to know the what to the theta. Hypotenuse. Now that we figured out what we know and what we want to know, we can figure out which trig ratio to use. Which one involves opposite and hypotenuse? Sine. So you do sine of whatever your angle is equal to opposite over hypotenuse. Now to solve this, you can put your trig function over 1 and cross multiply. So we're going to cross multiply here. That's going to give us x times sine of 24 degrees is equal to 11. 1 times 11. And then we divide both sides by sine of 24 degrees. This cancels out and leaves me with x equals. Now this is where the calculator does the rest of the work. 11 divided by 24 sine equals, and you should get about 27, approximately 27. It depends on, are you using what kind of calculator? That one, I think on that one you have to hit the, yeah, that one's a little bit different. I think you have to hit the sign first on that one. They're all a little different. Phone, you have to do number first, then the trig function.
So it's 11 divided by 24 sine.
Yep. It should work when you do it. Tell me if you get 27.
Yeah, I got like 27.
Yeah, then you got it, yep. Do you remember this from geometry?
I remember, I just wanted to know if I was doing it right.
Alright, 11 divided by 24 sine equals. calculator has to be in degree mode, not radian mode, because radians are another measure of degrees, and you can't use that. So if you convert it to degree, it should come out. It's assuming you're in radians, that's why. Forgot to mention that, thank you. You got it now? Yeah. Radians are like basically converting like inches to centimeters, so that's why it doesn't work. So for the next one, we're going to identify what we know and what we want to know. So this is our theta, so to speak. We already know what? We want to know the adjacent. What trig function uses adjacent and hypotenuse? Cosine. So cosine of 70 degrees is equal to adjacent over hypotenuse. We put our trig function over 1, and we cross multiply. We get x equals 15 times cosine of 70 degrees. X equals, so 70 cosine times 15. You should get about 5.13. Everybody good with that? Okay. Are we all ready for the next one? All right. So on this one, we have our theta. We know what side? We know the adjacent, and we want to know the what? What trig function is that going to be? Tangent of my angle measure is equal to x over 6. We put this over 1, and we cross multiply. We get x equals tan of 52 times 6, which means x equals about 7.68. And if there are units, put units. If not, no need to. Depends on what the question gives you.
So will we always round to decimal points?
What'd you say?
Will we always round to decimal points?
I would say to base it around what the question asks. Like on the quiz or test, I'll be very specific about what I want you to round to. Anybody have any other questions? On the homework, I don't care. It's fine to round to whatever, as long as it's, within reason. All right. So now we're going to talk about the last thing we're going to address today, which is going to be inverse trigonometric functions. You remember this using the second button? So when two side lengths of a right triangle are known, we can use the inverse trigonometric functions to find the unknown angle measures. These inverse trig functions are programmed into every scientific calculator or your phone. So the inverse of sine of x is known as sine, like with the negative exponent, or arcsine is the angle measure whose sine is x. So basically, don't confuse inverses with reciprocals. Inverse is something different. It basically works backwards to find the missing angle measure. So the way that I always would say it in geometry when we did this is if you want to know the angle, you have to use the inverse, okay? See how here we're looking for the angle instead of a side? That's how we know we use the inverse. So how we set this up is we treat this as theta just like we did before. And now we look at the two angles we know and we determine what kind of angles they are, or sides. So this side is what to the angle? This side is? Good. So what inverse trig are we going to use? Sine. So how we set it up is we do sine of x is equal to opposite over hypotenuse. You will now. So that was just the main setup. So now from here, what you do is you do sine inverse, then we take whatever this is equal to x. So that's what you're able to do when you are looking for the angle. So x is equal to, how you did this in your calculator, 6 divided by 14 equals, and then second sine, exactly. And what did you get when you did that math? Good. about 0.4. Do you get it?
Yeah, it's like sine h and like cosine h and tan.
No, that's hyperbola.
Oh. Oh yeah, okay, yeah.
You got it?
Second, yeah.
Yeah, don't use that.
Yeah.
Is everybody good with that?
Wait, so say how to do it again?
Sure. So you're gonna do whatever the fraction is, 6 divided by 14.
Okay.
And then does your calculator have like a second button?
Yeah.
Hit the second and then hit the sign.
Okay. Do 6 divided by 14 equals and then second?
Yeah.
Okay.
You got it.
I see. Okay.
Yep. So you're. No, so reciprocal and inverse are two totally different things. Yeah, I know it's confusing, but yeah, they're different. Is everybody good with A though? We get to try another one. So in this one, we know 15, which is what to the angle? 17 is hypotenuse. You only will ever have one of each. You good with that? Oh, okay. So this is going to be what trig function? Cosine of your angle is equal to adjacent over hypotenuse. When you have this set up, you can always flip it. So it'll be inverse cosine of whatever that fraction is equal to x. It's going to be x equals 15 divided by 17. Second cosine equals, I'm getting 28 degrees.
So inverse is when you're looking for the angle?
Correct. You always use the second button when you're looking for angle. If you don't know the angle, you'll be using the second button. Ready for?
So you do 15 divided by 17
equals
and then
second cosine equals.
Okay.
You got it?
Yeah.
We're going to do one more together. So in this case, here's our theta. We know 27, which is the? And we know 18, which is? Which is what trig function? Tangent of x is equal to opposite over adjacent. We can flip it. And then we can do the math. 27 divided by 18, second tan equals, I get about 56.3 degrees. So yeah, that's another side note, is make sure your calculator, phone calculator, is in degree mode. If you're in radian mode, you're not going to get the same answer. We'll talk about what degrees and radians are in the future. But